Hi everyone. Today we are going to be talking about network model. Network models give us a reference of how communication happens in a network. Consider it as a blueprint for network communications. There are two models. One is OSI and the other one is the TCP IP model. First, let's dive into OSI model. OSI stands for Open Systems Interconnect, which was developed in the year 1978 by a French engineer, Herbert Zimmermann. The OSI model is divided into 7 layers, where each layer has its own responsibilities. These are the 7 layers starting from the bottom. We have a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Every layer interacts with the layers present above and below it. Firstly, whenever it is that traffic is transmitted between two devices, the sending device will always start from the application layer and move its way down towards the physical layer. So let's say I have two devices here. This is device A. And this is device B. Both of these devices have been cabled. Let's assume device A is sending traffic and device B is receiving traffic. This is the transmitting device. This is the receiving device. Whenever it is that the device is transmitting, it will always start from the top layer, which is the application layer, the first layer, and it will move its way down towards the physical layer. Whenever it is that the device is receiving traffic, it is obviously receiving it on the physical medium. It's receiving it on the physical layer. So the receiving device is always going to receive it on the physical layer. And eventually the process, the communication moves towards the top, which is the application layer. Let's go through each layer briefly. Let's start from the bottommost layer, which is the physical layer. This layer is responsible for converting digital signals into electrical, optical, or radio signals over the physical medium. So, physical medium is basically considered as the physical layer. The physical layer also defines the direction of the flow, which can be simplex, where the data is flowing in one direction only, half duplex, where data can flow in both directions but not at the same time. And lastly, there is full duplex as well, where data can flow in both directions simultaneously. This physical layer also includes the type of medium that is used between the devices for communication, like copper cables, fiber optic cables, or even a wireless medium. This layer basically ensures that the transmitting and the receiving devices are synchronized so that data can be transmitted and received correctly. Examples of physical layers are adapters, cables, connectors, hubs, switches, modems, etc. Next is the data link layer. Data link layer is the second layer in the OSI model. It is definitely responsible for making sure that the traffic is transferred between the two devices reliably. It provides the following key features. So firstly, there is something called as framing. The data link layer packages raw bits, whatever raw bits have been received from the physical layer. It is put into a structured data unit, which is called as frames. This process is what is called as framing. Framing helps to organize data, making it easier to transmit and manage. Addressing. Whenever you are using data link layer, there is a form of addressing which is called as MAC address. MAC address basically makes sure that data is transmitted, data is sent between the proper source device as well as the destination device. Next is error detection and correction. So there are implementations to make sure to detect if there are any errors. For example, techniques like cyclic redundancy check, which is called as CRC, is used very commonly to detect if in case there are any errors and to immediately fix those errors as well, to basically manage those errors. Flow control. Flow control is basically used to make sure that whenever data is transmitted between two devices, there is prevention of quickly or fastly sending the traffic from one device where maybe the other device or the receiving device is slower, right? So there is always firstly synchronization between the two devices, because there may be a fast sending device and there may be a slow receiving device. So if that is the case, then there can be an issue. So whenever it is that two devices have to talk to each other, firstly have to start sending traffic towards each other, there is always firstly synchronization that takes place, and data link layer is responsible for it. Apart from this, there are also your network layer. Network layer is the third layer, quite important. The network layer is mainly for logical addressing. So whenever it is that we are using data link layer is layer 2, right? This is physical layer, which is layer 1. Data link layer, which is considered as layer 2. Then there is network layer. Some documents you may be able to see it as IP layer, which is layer 3. And then there is transport layer, which is layer 4. Session layer, layer 5. Presentation layer, which is layer 6. And lastly, application layer, which is layer 7. So your MAC address, which is the physical address of the devices, is always present on data link layer. On the network layer, you have logical addressing, which is called as IP. So that is what I have mentioned here, logical addressing. IP address exists on this particular layer. IP addresses are also logical identifiers that are used to identify devices across different networks. Routing, this is where routing takes place. It is on this layer, network layer, that is where routing takes place. Routing is the process of determining the best path to send the traffic from device A to device B. Based on that routing is how the packet is forwarded. There is fragmentation and reassembly that takes place. So fragmentation is nothing but dividing the traffic into multiple parts, into multiple packets, so that it's easier to send the traffic. Each of these divisions of your packet is what is called as fragment. And once you send it to the other device, the receiving device, the network layer on the receiving device is responsible for making sure that the packet is reassembled in the correct order. Error handling and diagnostics. So again, there could always be errors in any of the layers that you take, be it layer 2, be it layer 3, be it layer 4. There could be errors. So there are implementations in each of these layers to make sure that there is no packet losses, there is no duplication of any of the packets, and also to make sure that there are no errors. Traffic control and congestion management. The network layer manages traffic on the network to avoid any congestion. If there is any congestion of traffic, there will be very slow movement of traffic. Slowness will be there in your network. Next is the transport layer. Transport layer ensures that data is delivered accurately. It should be delivered in the correct order, and again, there should be no errors. Every layer will make sure that there are no errors. It handles flow control. It does error detection, make sure that there are no errors, and of course, eventually corrects them as well. And it does the data segmentation as well as reassembly. So again, like I mentioned earlier, whenever it is that traffic is sent from one device to the other device, that large chunk of traffic is basically cut into smaller pieces. Each of these pieces are called as fragments. They can also be called as segments. So segmentation is done on this particular layer, and it is also made sure that it is properly arranged on the receiving device. Next is the session layer. Before we move into session layer, another very important point, examples I would say for transport layer are TCP as well as UDP. So there are two types of protocols. One is TCP and the other one is UDP. More about TCP and UDP we will be discussing as we move ahead. Next is the session layer. The session layer is layer 5 in the OSI model, and this is definitely responsible for managing and controlling communication between two devices. It establishes, maintains, and terminates the connections between the applications to make sure that the session is established and it is closed whenever it is not required. Next is the session layer. Next is the presentation layer. Presentation layer is layer 6, right? Presentation layer is layer 6 in the OSI model. It is basically responsible for translating and formatting data for application level communication. Its main role is to basically ensure that data is properly formatted and presented so that it can be understood by the application. Okay, so certain examples of the presentation layer are basically formats like your JPEG, GIF, PNG. These are all certain examples of presentation layer. Encryption of data, decryption of data takes place over here. So whenever a device is sending any traffic, A is sending the traffic, B is receiving the traffic. Whenever the A device is sending the traffic, the presentation layer which is present on A is basically going to make sure that your traffic is encrypted, to make sure again that the data is safely sent, securely sent from A towards B. Once B has received it, the presentation layer on B is going to make sure that the traffic is decrypted. It should be understood by the device that has received the traffic. Okay. And lastly, we have the application layer. Application layer is the topmost layer, the layer 7 in the OSI model. It interacts directly with end user applications. So we as users are going to be using certain applications like your browsers, emails. These are certain examples of application layer. This is where we are going to be using, this is where we are going to be configuring whatever is required. Best examples of application layer are HTTP, HTTPS, SMTP, Simple Mail Transfer Protocol, FTP. These are all certain examples of application layer. application layer is where we as users sit and use these applications to provide us with services that we would require. So these are the 7 layers in the OSI model. Very similarly, there is a TCP IP model as well. So TCP IP model can also be called as the IP suite. This is also another blueprint that is available. OSI, you can say, then what is the difference between TCP IP model and OSI? Nothing. You can see here your top 3 layers, I would say, right? The top 3 layer, that is application layer, presentation layer, as well as session layer, have been combined into one layer, which is called as the application layer. Remaining are the same. Then you have the transport layer, you have the IP layer, internet layer, or also called as the network layer. And lastly is your physical layer. Practically, TCP/IP model is what is used. Theoretically, to understand the details of what each of these layers do, OSI model is what is used. Okay. So in a practical sense, you can just say TCP/IP suite or TCP/IP model is what is used to understand, used to represent what is happening. And the OSI model is more theoretical, where details of every single layer can be understood. So with this, we will end our session here for today. To know more, to learn more, please join our upcoming CCNA batch. The details to contact us is mentioned in the description box below. Thank you all for watching. See you soon.